Now we have line segments, rays, and lines. What's next? Of course, angles. You probably know the concept of angles, and we're going to build off of that in this lesson of chapter 4, even if it seems a little easy. Remember, you still have to pay your full attention. Anyway, so yes, this lesson will be working on understanding angles. And then, hooray, we're halfway through chapter 4. And this is actually, I think the next time we have angles would be in the next semester. So, yes. So after angles, we have coming up comparing angles, basic understanding of polygons and circles. So let's get started. Here's the learning goals for today. First, understanding the concept of angles and mastering the representation of angles. So we're going to learn how to represent angles, such as how in the first lesson we learned how to represent lines, line segments, and rays. 2. Learning and knowing how to use the protractor correctly and understanding the common measurement units for angles. So from now on you'll need a box of rulers if you don't have them yet. And the protractor is one of the rulers in there, and we'll learn how to use them. And the last one, knowing how to do simple conversions of degrees, minutes of an arc, and seconds of an arc. So here's an introduction. Can you find any angles from the following pictures? One picture. So here's are some pictures. Now I want you to find any angles you can see. Well, the first one, of course, there's the blades right there, the scissor. Those are an angle. Another one, there's the arms of a clock. That's an angle. The rooftops of a castle. That's an angle. And the how a table stands cross each other is an angle. So, the concept and representation of angles. What are angles and how can we represent them mathematically? So here are two angles, AOB and EDC. And I have 3 questions for you. 1. Can you point out the edges and vertices of the figures drawn? Or the edges and vertices? And 2. What shapes are on the 2 sides of the vertices? And what is their positional relationship? Can you describe what kind of geometric shapes are called angles? All done answering these questions? Okay, let's move on. Here's the conclusion. The figure composed of 2 rays. Okay, so remember this is the definition of the angle. An angle is a figure composed of 2 rays with a common start point. And that's called an angle. The common start point of the 2 rays is the angle's vertex. And the 2 rays are called the 2 sides of the angle. Jot these all down in your notebook. Alright, if you haven't, pause the video or go back. And we'll move on to the next slide. So now we have some discussions. I'm going to put up a few shapes and you're going to tell me if they're angles. Are these angles? So the answer is none of them are. The problem is that they're all lines or line segments, or they could be rays, but whatever they are, they don't share one same start point. And we're not sure if they're rays or not, so yes, none of them. Now I want to answer all 5 more questions. The first question is, what is a geometric symbol that represents the angle? The second question is, and of course you can observe what's going up on here. How many ways are there to represent one angle? Great. 3. What should I pay attention to when using 3 capital letters to indicate an angle? 4. Under what circumstances can the vertex of the angle be used to represent this angle? And 5. I'll wait for your answer for 4. Yes, so 5. What should be paid attention to when using Greek letters and Arabic numerals to indicate an angle? Let me go over all the answers of these. So, what is geometric symbol that represents the angle? The geometric symbol would be you've probably seen this before. Say we want to mark ABC. The angle would be ABC or CBA. But remember that start point right there? You see how there's B is a start point? The letter of the start point always has to be in the middle. So you could flip around the A and C, but B is always in the middle. And this is the geometric symbol that represents the angle. And then, how many ways are there to represent one angle? Okay, I'm going to erase this. Got that? Okay, the geometric symbol of the angle is this. And of course, the vertex always have to be in the middle. Okay, so question number 2, how many ways are there to represent one angle? There are actually quite a few. There's the one we just went over. There's one that you could go, like, for example, you have this, right? You could go angle 1 or angle 2, angle 3. For this one, it was using, this is called a beta. And this is probably one of your first time seeing it, because you might think, wow, that looks like an English B. Well, what it is the second letter, beta, from the Greek alphabet. So sometimes we would use Greek letters and Arabic numerals to represent an angle. And what should I pay attention to when using the 3 capital letters to indicate an angle? Remember the thing we just went over? The letter of the vertex is in the middle. I'll just write mid for that. Okay, and 4. Under what circumstances can the vertex of the angle be used to represent this angle? Well, the vertex of the angle. Under what circumstances? So the vertex of the angle can be used to represent this angle when... Oh, okay, one more thing. So you see how over here there's BOC? Another way to represent it, it could be called angle O. Angle O, the O is the letter of the vertex of the angle. So it's called angle O. But here's the catch. What circumstance can be the vertex of the angle to be used to represent this angle? You can only use this way when there's only one angle coming out from one vertex. For example, in these two angles, there's two angles, actually no, 3 angles coming out of vertex O, and over here there's actually 4 angles, this larger one AB, COA, are coming out this angle. So if you just say it's angle O, well, there's many different angle O's, so we won't be able to know which angle O you're talking about. So be aware of that. And what should be paid attention to when using Greek letters and Arabic numerals to indicate an angle? Well, what should be paid attention to? So Greek letters, just be clear with them. Be clear with them when you're indicating. Now another discussions. So over here, I have the angle AOB. So the representation of this would be angle AOB or BOA. But remember, O, the vertex of the angle will always have to be the middle letter. Now, what's this angle? This representation could also be angle O because there's only one angle emerging from it. Now we could call this angle alpha. This letter is the alpha of the Greek, the first letter of the Greek alphabet, and the representation could be angle alpha, and this could be represented as representation angle 1. Easy enough. Here's a conclusion of the angles representation methods. Method 1, using 3 capital letters. Here's an example, AOB or BOA. And the application is any angle. Method, oh, by the way, this is something you should be paying attention to. And if you're not paying attention, or if you think you're gonna lose what I'm saying right now, jot this down. So, if you think you're gonna have trouble memorizing what I'm gonna say right now, you should jot this quickly down in your notepad. Now, of course, when you use just one capital letter like angle O, the vertex of the angle, there is only one. You can only use it when there's only one angle at the vertex. If you say you have one more emerging from here, then you couldn't use this. You couldn't use this way because you wouldn't be sure which angle O you were talking about. Now we have using a number or Greek letter. So there are arcs and numbers, arcs and lowercase Greek letters. Now here's some DIY or do-it-yourself. Are the angle representations from the following picture correct? If not, what is correct way? These are, you see angles 1, 2, and 3. Try to see if they are the correct way. Now let's look at the first one. We are representing angle 1 as angle A. So here's angle 1. Would it be okay if I change this into angle A? In this case, no, because there are many different angles emerging from it. There's this angle, of course. There is this other angle here. That's angle A, could be angle A. And there's this larger angle right there that could be angle A as well. So you wouldn't be sure which was angle A, so that would be incorrect. Second one, representing angle 2 as angle D. Well, is that correct? Yes, it is, because there is only one angle. Wait, I'm sorry. So, no, it's wrong, because, yes, there is this angle, but there's also this angle that's 180 degrees, and there's also this smaller angle on the other side. So that's also incorrect. And representing angle 3 as angle C. That's also incorrect, because first there's this angle that angle C has, there's this angle, and there's this angle. So there's multiple angles, all of these are incorrect. Do you still remember that definition of the angle we learned earlier in this lesson? Yes, I was talking about how an angle was like two rays starting at the same start point, and that would be an angle. That's correct. And here's another definition. As shown in the figure, an angle can also be seen as a ray rotating around its endpoint. So, as you can see, here is point O, and then this is two rays, or in this case, we're seeing it as one ray. What it's saying is you could think of it as this angle, and it's rotating upwards around O, and the infinite space in here would be the angle. Is that correct? Of course it is. There's also another way. You could think of it as right here, and then you actually rotate this way. So it would be a more than 180 degrees. And this space over here would be the angle. Sorry, my drawing's a little bad, but you should get the point. For example, the paper cutter forms angles of different sizes while it opens and closes its blade. So what I'm saying is this whole section right here is the angle. Angular units and calculation. Now here's the hard part they probably didn't heard about before. Before we get into this, I need to ask you about a question. Have you ever measured angles before? You probably have. We probably encountered something like it. And what was that unit you were measuring in? The one with that little circle at the top right of the number and all of that? Yep, that was called degrees. Such the same degrees. Well, not the same degrees, but not the same meaning of the degrees as degrees Fahrenheit, degrees Celsius, but for angles. So back then, you probably thought that was the only unit you could measure angles in. But what about smaller angles? How do you measure those? That's what we're going to learn in this section. But before that, here's the concept of straight and full angles. 1. A ray rotates around its start point. When the ray lines up with the other ray spinning a full 180 degrees, it is called a straight angle. For example, this is a whole straight angle. And second, if the ray continues its rotation fully and comes back to the beginning position, and mind you, if that's a full rotation, that would be a 360 degrees, and it would be called a full angle. This is an animation of that angle. Starts here and then moves all the way around the full circle and comes back to where it started. One straight angle is equal to 180 degrees, and one full angle is equal to 360 degrees. Think about this. How do you know about the size of an angle? Well, you could compare angles. You could just measure them directly. And here. Angle measurement tools. Protractor. Was that ruler you saw earlier on? You probably have this in your ruler set. It's that semicircle kind of, with marks littered over the edge of it. And then angular units, degrees, minutes of an arc, seconds of an arc. What are those? We'll get into that. Now here's we have to start paying attention. So 1/60th of 1 degrees is 1 minute of an arc, written as 1 with the apostrophe. So 1 degrees is equal to 60 minutes of an arc. Pay attention to the word minute of an arc. What's it called a minute? Well, think about the clock. How much minutes are in 1 hour? 60. Next one. 1/60th of 1 minute of an arc is 1 second of an arc, written as 1 with 2 apostrophes, or yes, 2 apostrophe. And so 1 minute of arc is equal to 60 seconds of arc. If you're good with the clock, you probably know this real well. But don't worry if you don't get it yet, because this is a very, very new concept. So review. 1/60th of 1 degree is 1 minute of arc, written as 1 with an apostrophe. So 1 degree is equal to 60 minutes of an arc. And then 1/60th of a minute of an arc, even going smaller now, is 1 second of an arc, written as 1 with 2 apostrophes. So 1 minute of an arc is equal to 60 seconds of an arc. Lots of words. Hope you get what I mean. So let me ask you a quick question. How much seconds of an arc are in 1 degree? Well, you times together the 60s, which is 3,600. Now I'm going to show you a very, very important diagram. You'll need this later on, I guarantee you, and you need to jot this down. Here is the relationship between the degrees, minutes of an arc, and seconds of an arc diagram. First you have degrees, or 1 degree. It goes down to minutes of an arc. And that's a times 60, because there's 60 more minutes of arc with every degree. And that would be divided by 60. There's 60 less degrees than every. Yeah, so basically you got the idea, because there's 60 minutes of an arc in 1 degree. And a minute of an arc goes down to seconds of an arc. And that's times more 60, because there's 60 times more seconds of an arc. So the other way around would be divided by 60 to get from how much seconds of an arc to minutes of an arc. This is a very important angular calculation, by the way. And degrees. A degree going down into seconds of an arc is times 3,600, which is because there are 3,600 seconds of arc in 1 degree. And the other way around is divided by 600. Voila, that's the relationship between degrees, minutes of arc, and seconds of arc diagram. You don't have to memorize it, and you won't have to if you jot this down, so right now I'm waiting. All done? Okay. Now we have to do the calculation. If you just jotted down what I just told you to do, then you would be able to do this. Calculate all of these questions and then come back and then we'll go over them together. First question says how much minutes of an arc and how much seconds of an arc is 1.45 degrees equal to. So here's a solution. The first one, it says, I just read the question, you times a 60. Don't be freaked out when you see these decimals. Just times that 60. That's all you have to do. Which is equal to 87 minutes of arc. That is that apostrophe. And then for this, you're going to, and we already know that this is equal to 87 minutes of arc. So you times 60 again to get 5,220 seconds of arc. Second question. 1,080 seconds of an arc is equal to how much minutes of an arc? And how many degrees is it? Well, we divide 60 to get to 30 minutes of arc. And then since we already know that 1,800 seconds of arc is equal to 30 minutes of arc, then 30 minus 60 will be the degrees, which is equal to 0.5 degrees. And 45 degrees and 2. So, mind you, this is one whole value here. Is one whole thing. So 45 degrees, 25 minutes of arc, and 48 seconds of arc is equal to 45 degrees plus 25 minutes of arc plus 48 divided by 60 minutes of arc, which is equal to 45 degrees plus 25.8 minutes of arc, which is equal to 45 degrees plus 25.8 divided by 60 degrees, which is equal to 45.43 degrees. Hope you got these all right. If you're confused about anything, you might want to skip ahead to where I start explaining what these are. And actually, you know what? I'll just explain it again. So, quickly. 1 degree is equal to 3,600 seconds of an arc and 60 minutes of arc. 1 minute of an arc is equal to 60 seconds of arc, and 60 seconds of arc is smallest unit we're going to at least learn in this unit. So here's a method summary. Based on 1 degree is equal to 60 minutes of arc, and 1 minute of arc is equal to 60 seconds of arc. First convert both amounts into using the same unit of measurement, then calculate. So in measurement, in all the other measurements, like weight, height, you probably encountered that you had to turn them into the same unit of measurement, then you calculate. You can't just add different units together. If I said, add these fruits, and you see 7 oranges, 2 apples, 5 pears, and 3 apples, and 8 pears, you can't just add them together. Well, I mean, unless you had a fruit punch mixer, of course. But you wouldn't say, because you wouldn't say 8 pears and 2 apples. You can't say that, they're not combined. You have to say 5 apples. That's the only way you can put them together, because the unit apples is the same. Here's a conclusion. When adding, subtracting, multiplying, dividing degrees and minutes of seconds of our arc, pay attention to the following 3 points. 1. Degrees and minutes in seconds of our arc are 60 based. 2. When doing operations of addition and subtraction, you can use the concept of borrowing when there is not enough. And 3. Multiplication and division operations can be carried out according to the distributive property, and the remainder can be converted into a low-order division if it is not divided. So now we have a class summary. We learned all about angles through their definitions or concepts, and we learned all about concept of angles, representation of angles, and measurement and calculation of angles. The skills we learned was understanding the concept of angles and mastering the representations of angles, knowing how to use a protractor correctly, and understanding the common measurement units for angles, and knowing how to do simple conversions of degrees, minutes of arc, and seconds of arc. The next lesson we'll be learning all about comparing angles. And in case you wondered why this lesson was so short, since like all the other videos are crazy 45 minutes long, and this one was just like 20 minutes, I guess. Why? Well, the reason was because, those old 45-minute videos, seriously, you expect me to watch that? We didn't want that from our viewers. So those problems, we are putting them into worksheets you can find on our website shortly. We are going to do that soon. And later on, we will start publishing workbooks on Amazon. You'll probably find that later. We'll put the links in our later videos. So be on the lookout for that. And yeah, I hope you understood the concept of angles. If you didn't understand anything, you can always go back. And please just comment, subscribe, share, and smash that notification bell button. So stay inquisitive. What is up with me? And we'll see you next time.